first day of my school at Malverne High School.
I'm an 11-year-old and I'm now officially in 12th grade at Malverne High School. In 3 months, I will be applying to Harvard to get into my bachelor's degree for physics. Today, the leadership of my school district, including Superintendent Dr. Lewis, Principal Dr. Romano, Assistant Principal Miss Bascombe, and my guidance counselor Miss Scotsman, invited me to present my new math discovery to them and discuss the steps I need to take to apply to Harvard.
Because I want to keep this, so when you get your Nobel Prize, you'll remember that you were here in Malverne, that we nurtured you. Or you nurtured us, either way. Both ways. I'm sure you gave a lot to your classmates, and your classmates did a lot for you.
Hello, Professor Bari. How are you? I'm so pleased that you're in the Malverne School District and you're doing so well.
Where do you see yourself 5 years from now?
Probably getting my PhD.
Really?
Yeah.
Where?
At one of the Ivy Leagues, hopefully. But if I don't get accepted to one of those, even though I have all these accomplishments behind my back, I could probably get accepted to a university like NYU, for example.
Don't lose your goals. We can work on getting you where you need to be. That's what we do in Malverne, and you certainly have all the skill sets, certainly mathematical skill sets, to be able to accomplish your goals. So this is pretty impressive.
Hello, Suborno. Congratulations on your graduation today. Malverne High School Principal, Dr. Vincent Romano. We're looking forward to having you at our school. It's going to be a privilege and an honor for you to excel and take advantage of all the opportunities we have to offer. And I know you're going to do just that.
Black. I wanted to present my paper, which has a really long, gnarly title, but don't be scared by it, because it's just how formal everything needs to be when you're trying to publish an academic paper. I was lecturing at a pretty prestigious university in Bangalore, India, named Jain University, and after the lecture, I was a little bored, so I started getting curious what happens when you add more shapes to a polygon, and I saw, well, it leads to a circle. But I thought, well, you can't assume anything in mathematics, so how can you prove that? So I used a function in order to prove that, and then I started analyzing that function, which led to the basis of the paper. Then I emailed my mentor, Dr. Kabat, who is an MIT graduate. He has his PhD from MIT, and he's a professor at CUNY Graduate School. So, and he gave me a few recommendations that I'll list. But first, let's start simple. We have n equals 6 here. That's a hexagon. And obviously, you can see that if I draw a circle around all of these shapes, you can see that as we increase the number of sides, it starts looking more and more like the circle that's circumscribed around it. So the hexagon almost leaves no area within the circle. The pentagon leaves some area within the circle. The square leaves a lot of area, and the triangle leaves a really big area. So, does that mean that as we approach infinity sides, then our polygon will just be a circle? Well, I want to find out, and my obvious intuition was saying, well, it's true, but I wanted to find out with some sort of proof. So I started by calculating the perimeters of these things. Well, in terms of their sides wouldn't be enough because we don't really have an equation for the perimeter of a circle in terms of its side length because it doesn't have a side length. So instead, I was going to use the radius of a polygon, which is also known as its circumradius, which is basically the distance from the center of the circumscribed circle all the way to one of the vertices. So this length is known as the circumradius, and it's analogous to the radius of a, oh my gosh, cursed with these markers. This is analogous to the radius of a circle. So, how can we find the perimeter of this triangle with that circumradius? Well, we can do it pretty simply. There are two ways going about this. The first was the one I imagined, which is this way. You can just split the triangle up into 3 isosceles triangles. And then, since each of these are the same length, they have to trisect this 360-degree angle in the middle, splitting it into 120, 120, and 120. And then, using something known as the law of cosines, we can find the length of this length, not squared, 120 degrees. We can find this side length in terms of the radius, r, using the law of cosines, which says that if we have A, B, C, and this angle is C, then we can say that C is just equal to the square root of A squared plus B squared minus 2AB cosine C. So, using this method, because our A and our B are both R, we can just plug that in. We have R squared plus R squared minus 2R squared cosine, well, what is C? Well, if we think about it, in our triangle, we have split this 360-degree angle into 3 angles. But if we had a hexagon, like this one, and we drew all of the circumradii, we have 1, 2, 3, 4, 5, 6 lines going through the center. So that would split it up into 6 equal parts. So that means that that means that this angle right here is just equal to 360. Oh my goodness, these markers. 360 divided by the number of sides. So, and it's still ongoing.
Yeah, I like that notion of that learning is ongoing, and that's a great mindset, that you continue to look for new concepts. So, bravo.
How can you apply their concepts in real world?
Yeah, that is a very difficult question. A lot of math, there's an entire field called abstract math, which is done without the purpose of real application. But everything in math finds an application eventually, whether it be now or later. So I'm hoping that will include this paper. But for right now, I don't have any applications in mind, just math.
But you're definitely going after the PhD route for abstract mathematics.
Yeah.
Well, what about physics? What about?
Yeah, I might be going into either math or physics.
Yeah.
That's
where you take the mathematics into the real world. Mm-hmm. So that's great.
Suborno, congratulations. We are so incredibly proud of you.
What surprised you, if anything? Was there something that you learned that you said when you started this that you had, your idea was that it was going to go this way, so you set out to prove it? Was there anything that surprised you along the way?
Well, there was like one surprise at the beginning. When I derived that first function, it had like a moment of joy, and I decided that was enough work for today.
Does that surprise you?
Yeah.
What does your brother do?
He's currently first degree in physics.
Where?
At CCNY. He's taking one of the most advanced physics classes. I believe it's in thermodynamics. And
That was a hard one for me.
yes, he's moving on really quickly to do his PhD in physics.
At City College?
No, he's applying to an Ivy League's program.
Oh, okay. Well, so it certainly runs in the family, the interest in science and mathematics. So I know that your dad must have a lot to do with it.
Yes, he's doing his PhD in math at Columbia University right now.
Well, Your dad?
Yes.
Oh, fabulous. All in the family. Well, thank you so much, Suborno. I've known of you and have watched you since you entered, and thank you for choosing Malverne. And I hope that you found that we've accommodated your unique talent, and that whatever we can continue to do for you, we will do that. Whether it's Dr. Romano or Ms. Bascombe, who's going to be your new principal, Ms. Goddison, who's also going to be looking out for your best interest. All right, we'll take one for Central and one for the building. Okay? Oh, from President Obama? Right.
Oh, you wrote a book?
That is what, how could we get extra copies?
I mean, they're available on
Amazon? Okay. Say no more. We will get more. Very good. Well, can I have an autograph?
For Advanced Placement Calculus BC, congratulations to Suborno Bari. For Advanced Placement Physics, congratulations to Suborno Bari.